Hi chemistry class, welcome to another installment of your online chemistry lessons. Today we'll begin to learn about stoichiometry. One of the top selling toys of all time is Mattel's Barbie. And Barbie, so in honor of Barbie's success in sales, I'm going to base the theme of this lesson on stoichiometry on the Barbie doll. Okay, isn't she lovely? So moving right along, at the Mattel factory where they put Barbies together, the workers will assemble a Barbie using one head and body, and then two legs, and then they'll take two arms and pop them into place, and then also they'll need to put a dress on Barbie, so she's outfitted with one dress, as you can see up above here, and then on the dress they need to sew in 3 buttons. Okay, so that's how we put together a Barbie. And so as a result, we end up with one complete Barbie out of all these parts. So the parts get put together and we end up with a Barbie. So I guess that would have been making the prototype Barbie, right? You put one of the head and body, 2 of the legs, 2 of the arms, 1 dress, 3 buttons, you get 1 prototype. But then once they moved from the prototype stage and they moved into production, let's say they wanted to make 1,000 Barbies, for example. Okay, so now they've got to have a lot more parts. In fact, they've got to have basically 1,000 more of each type of part. So when it comes to ordering the head and body component, they're going to need 1,000 heads and bodies. And then instead of just 2 legs now, they're going to need 2,000 legs. And they're going to need 2,000 arms, because normally they would need 2 arms for just one, but we're ordering 1,000 Barbies, so we need 2,000 arms. Dresses, we're going to need 1,000 dresses for our 1,000 Barbies, and buttons for our 1,000 Barbies, we're going to need 3,000 buttons, because it's 3 buttons per Barbie. Okay, and that makes 1,000 complete Barbies. So as you can see, we're using ratios here. All the materials here were multiplied by 1,000, but they stayed in the same proportion to each other. Number of heads to number of legs stayed in the number of proportion. Number of heads to number of arms stayed in the same proportion. Here we go. So for example, the ratio of heads to bodies, the ratio of head and bodies to legs is, okay, so for every 1 head and body, we end up with 2 legs that pop into place. Okay, another ratio here, the ratio of arms to dresses is, okay, well, for every 2 arms, there will be 1 dress. And there are 2 armholes in that dress for the arms to go through. The ratio of buttons to legs, again, is 3 buttons for every 2 legs. You can see how these ratios come along. So even when we discuss the complete product, it stays in the same proportion with its reactants, maybe that's not the right word, with its components. The components that make up the product stays in the same ratio. So the ratio of complete Barbies to legs would be, well, 1 complete Barbie is made up with 2 legs. Okay, and that ratio will always be the same. The ratio of buttons to complete Barbies is 3 buttons for every 1 Barbie. Okay, so we've always got to be aware of these ratios. Sometimes in the Barbie factory, in the Mattel factory, there'll only be 300 buttons available to make Barbies with. And the factory managers will need to know at that time how many other materials should they order to go with those buttons, and they'll need to know how many of the final product they can ship to their customers, given that they'll only make a certain number of Barbies with those 300 buttons, which aren't very many buttons. So they'll need to do certain calculations with ratios. For example, they may put together a ratio of the head and body to buttons, and like I think we said before, we'll have 1 head and body for every 3 buttons. So if you're trying to calculate how many head and bodies will go with the 300 buttons that you have in inventory, what you'll do is you'll take, so number of head and bodies, okay, will be equal to our 300 buttons times that ratio of head and body to buttons. So 1 over 3, and that gives us 100. So we know we'll have to have at least 100 head and bodies in order to go with our 300 buttons so that everything gets used up. When it comes to legs and knowing how many legs we have to order to go with our buttons, so the number of legs, let's do our ratio. Okay, so it's 2 legs to 3 buttons. So the number of legs that we'll need to order will be 300 of our buttons times 2 legs for every 3 buttons. So that's going to give us 200 legs. So if there are 300 buttons available, we'll need to have 200 legs to go with those 300 buttons. Arms to buttons. So 2 arms go with every 3 buttons. So it's similar with the legs. So number of arms, number of Barbie arms you'll need to combine with our buttons will be 300 buttons times 2 over 3, 200 arms. Dresses, the ratio of dresses to buttons will be 1 to 3. So our number of dresses to order to go with our 300 buttons is going to be 300 times 1 over 3. 100 dresses. Okay, and finally, if we're trying to find out how many complete Barbies will we make with our 300 buttons, we'll just do a ratio here. 1 Barbie is made with 3 buttons, so therefore number of complete Barbies is going to be equal to the 300 times 1 over 3, 100 Barbies can be made with 300 buttons. Okay, another example of a factory question here. Sometimes an order will come into the factory for an extra large number of Barbies, and the factory manager will need to check their stocks, their inventories, to see if they have enough legs or enough dresses to meet the order. So here, for example, if we have 15,000 Barbies that need to be produced within the Mattel factory, then we'll need to take a look. Do we have enough legs? So the ratio of legs to complete Barbies again is 2 to 1. 2 legs go into 1 Barbie. So the number of legs we need, we'll have to check our bins within the factory, check our suppliers to see if we have enough. We're going to multiply 15,000 times 2 over 1. Okay, so we end up finding out that we need 30,000 legs to meet our order requirements. And ratio of dresses to complete Barbie. So trying to plan for the number of dresses that we would need, you need 1 dress for every 1 Barbie. So the total number of dresses that you would need for your order of 15,000 would be 15,000 times 1 over 1 gives us 15,000, which was kind of obvious, but just spelling it out here. So 15,000 dresses for 15,000 Barbies. Okay, now getting back to chemistry and getting away from the Barbie example, here we have in front of us an example, an equation for the synthesis of magnesium oxide. So magnesium plus oxygen get together and form magnesium oxide. So in other words, 2 magnesium atoms combine with 1 oxygen molecule, and when they combine, they make 2 magnesium oxide compound units. Okay, so this looks like another opportunity for us to use the numbers in the equation to come up with ratios. For example, so here this question says, how many magnesium oxide units can be made from 8 magnesium atoms? Okay, well, the ratio of magnesium oxide to magnesium atom in the equation, if we look at the coefficients in front of those compounds and atoms, is basically, so magnesium oxide is 2 magnesium, we've got a 2 in front of it, so the ratio is 2 to 2, or basically if we reduce it, it's 1 to 1. So if we have 8 magnesium atoms going in as reactants in a reaction, then the number of magnesium oxide compound units that will be formed as a result of that reaction will be 8 magnesium atoms times the ratio of 1/1. We'll end up with 8 magnesium oxide compound units. Okay, so the same thing goes for Barbies as it does with chemical equations here. So we end up with 8 magnesium oxide. So how much oxygen is needed to react with the 8 magnesium atoms? Well, let's take a look at that ratio then. So we've got we've got oxygen. We're just going to have a ratio of oxygen to magnesium, and we've got 1 oxygen atom for every 2, or 1 oxygen molecule for every 2 magnesium atoms. So the ratio is 1 to 2. So if we're looking for the number of oxygen molecules, that's going to be equal to 8 magnesium atoms times the ratio of 1/2 gives us 4. Okay, 4 oxygen molecules. And so we know that 4 oxygen molecules will react with 8 magnesium atoms in that chemical reaction. Okay, so in this next example here, where it's asking us how much oxygen is needed to synthesize 28 compound units of magnesium oxide, how much oxygen is needed. So 28 compound units of magnesium oxide. The magnesium oxide is the product, but we can still find how much of this oxygen, which is a reactant, is needed. So we'll just need to put together a ratio again. So the ratio will be the oxygen to the magnesium oxide, and that ratio is 1 oxygen molecule for every 2 magnesium oxide compound units. So therefore, if we're trying to find the number of oxygen molecules, that's going to be equal to our 28 compound units of magnesium oxide times 1 oxygen molecule for every 2 magnesium oxide compound units, which gives us our 14 oxygen molecules.